I'm now going to show you how to do the Bayes theorem problems. Most of the Chapter 6 problems will be of this type, and the way you recognize these types is that you typically have two different events, and you're going to study the relationship between those events. And there are really two ways of doing these. Actually, there's three ways. You can either use the formulas, and I don't recommend that. A second approach is to use a crosstab, which Siegel calls the conditional probability table. The third way is a tree. I'm going to show you how to use the crosstab in this video, and in another video I'll be showing you how to do the tree. So let me just point out to you the rules for making a crosstab. And this is not going to mean much until we actually look at a concrete problem. But let's take a look. So the first thing that you want to do when solving these problems is identify what's given. Then you're going to complete the table. And you're going to complete the table as follows. You enter all the marginal probabilities into the rows or columns. You will remember that the totals all sum to 1. You're going to enter in only joint probabilities, and then you'll find the other joint probabilities in the table and then answer the questions. So that's terribly abstract, I think, at this point. Let's make it a little more concrete by looking at a real problem. So let's take a look at number 3. I'm going to go over to PowerPoint, where I've actually typed all of this in. If we move this, we'll get this PowerPoint going. So your firm has classified orders as either large or small in dollar amount. So here's event 1. So think about this. You've just shipped an order. So you don't really know much about this order. And either that order was a large order or a small order in dollar amount. So you can think about that as being a random experiment, where you're going to observe whether it's a big, an expensive order or not so expensive. We also classify our orders in terms of heavy or light, presumably because of shipping. So maybe there are certain things that happen if it's a heavy order. So in the recent past, 28% of orders have been large, 13% have been heavy, and 10% have been large in dollar amount and heavy in weight. So if you think about the steps, the first thing I said to do was to identify the given. So let's take a look at this statement. 28% of orders have been large dollar amounts. So if L is the event that something is large, probability of L is 0.28. We were told that in the given. Now let's look at the next thing that we were given. So 13% of orders have been heavy. So if H is the event that something's heavy, the probability of H is 0.13. The third piece of given is that 10% of orders have been large in dollar amount and heavy in weight. One of the tricks to doing these problems is looking for certain keywords. And is one of those keywords. Or is another one. Or, remember, leads you to the or theorem. Another really important one is something like given. So given that the orders are heavy, blah, blah, blah. All right, so that tells you have a conditional probability. The word and here is telling us that we have a joint probability. So we could write this as L and H, or if you want, you could use an intersection sign. Now, the next step is to complete the crosstabs. And here are those rules that I had on the slide. So enter marginal probabilities into the margins. So this area out here is a margin. This area down here is a margin. So let's enter those probabilities. So we know the probability of L is 0.28, probability of H is 0.13. Now the size of the crosstab is 1. Think of this like a Venn diagram. It's your entire sample space, therefore it has area 1. From that we can use the complementary rule to deduce that the probability of not H is going to be 1 minus 0.13, or 87%. The chance of not large being 1 minus 0.28, which is 72%. So we've already figured out the margins. Now the next rule is this. Enter only joint probabilities. So those are things like probability of A and B. Well, in this problem, remember we were given an L and H, so we're allowed to just drop that into the crosstab. And so I'll drop that into this cell up here. So the probability of L and H is 0.1. Now, the next step is to figure out the rest of the joint probabilities. And the rules are pretty simple on this. The rows add up to the row totals, the columns add up to the column totals. So 0.1 plus whatever this cell is has to be 0.28. Therefore, this cell, the probability of having a large order that is not heavy is going to be 0.28 minus 0.1, which is 0.18. Let's look at this, this cell down here, which is heavy and not large. Well, the probability that it's heavy and not large, plus the probability that it's heavy and large, remember there's two ways to have a heavy order. It's either large or not large. These two things have to sum up to 0.13. Therefore, if we subtract 0.1 from 0.13, we find that the probability of heavy and not large is 0.03. Then you can take either one of the other ones to deduce that this probability is 0.69. So you'll note that these four numbers, the four numbers in red, all add up to 1. All right, if you can get this far, I claim that the rest of the problem is easy. If you can't get this far, then go watch the video again. So let's go answer the questions. The first one is, what is the probability that an order is large in dollar amount or heavy or both? So what this is saying is it's large or heavy or both. There are really three ways that you could do this. So one way is to use the OR formula. So we just did two problems involving the OR formula. If you take 0.28 plus 0.13 and subtract the intersection, you get 0.31. And another way that you can do this, large or heavy, is just to add up these three cell probabilities. So we've shaded these three cells, just add up 0.03, 0.1, and 0.18. Notice you still get 0.31. The third way is to use De Morgan's laws. So remember that these three shaded areas equal 1 minus the thing that's not shaded, which is 0.69. And if you take 1 minus 0.69, you get 0.31. I don't care which approach you use to finding them, but I do think it's worth knowing all three approaches. So let's move on. What is the probability that an order is for a large dollar amount and is not heavy? Well, here's one of those key words. The word "and" is tipping us off that they're after a joint probability, and we just go, pick that right out of the table. So the answer is 0.18. So see how easy this is once you have your crosstab table done. Of. Okay, so of is another one of those important words. Of often indicates that you're restricting your universe. So let's read what this says. Of the orders with large dollar amounts. Sure enough, we're restricting our universe to only orders that have large dollar amounts. So now we just care about that red row. So of these orders with large dollar amounts, what percentage are heavy? So we're saying how big is this cell, 0.1, to the row which has mass 0.28. So 0.1 divided by 0.28 is 0.36. So 36% is that conditional probability. Again, once you see the word of, that probably means that you're dealing with a conditional probability, and you'll be using this formula. Next part reads given. Okay, so given is another one of these keywords. Given an order is heavy means live in this column. You don't care about the whole sample space, you just care about the 13% of the orders that are heavy. So given that it's heavy, what's the chance that it's for a large dollar amount? So we're saying how big is 0.1 to 0.13? So 0.1 divided by 0.13 is 0.77, and that's the correct answer. Are the events large dollar amount and heavy mutually exclusive? Well, the way you work this problem is to remember the definition of mutually exclusive. So the events are mutually exclusive if the probability equals 0. Now in this case, the probability of large and heavy at the same time occurring is 0.1, so they're not mutually exclusive. What that means is they one does not preclude the other from happening. They can both occur at the same time. So just go back to the definition of mutually exclusive and you're pretty much done. Finally, are they independent? Well, remember what independent means. Independent means any of these three things, so they're all equivalent. So if they're independent, you have all of these things. Likewise, if you have any one of these three bullets, then you can conclude that they are independent. So pick any one of them and check it, and you're going to conclude that they're not independent. So let's just take a look at the first one. So is the joint probability, which we're told is 0.1, equal to the product of the marginals? Well, no. Therefore, they're not independent. There seems to be a typo on this slide, but the probability of L given H was something we found to be 0.36, and that's not just the probability of L. So that's another way to do it, and likewise you could find the probability of H given L, which is not equal to the plain old probability of H. So information about the other event changes our evaluation of whether an event occurs. So that's it for this problem.